Good afternoon, good afternoon, good afternoon. Hope all is well. Everyone's doing all right. Looks like everyone is in. Okay, so today we are looking at chapter 10, if I'm not mistaken. All right, let me pull up the notes. I can do the other one. All right, so 10.1, language of hypothesis testing. See if I can magnify it a little bit. All right, so language of hypothesis testing 10.1. Your hypothesis is a statement regarding a characteristic of one or more populations. Hypothesis testing is a procedure based on sample, evidence, and probability used to test statements regarding a characteristic of one or more populations. So 10.1 and 10.2 is all based on hypothesis testing. There are three scenarios that we're going to run across, and you'll see them as we get there. But that's what 10.1 and 10.2 are about, hypothesis testing. Anybody still holding on to that first sentence? Let me know. All right, steps in hypothesis testing. And they give you these steps if you were starting from scratch. You know, of course, when you guys get your problems, you won't be starting completely from scratch, because they're going to give you the scenario, give you the statement and all the stuff like that. But they give you the steps in hypothesis testing if you start from scratch. So you're going to make a statement regarding the nature of the population, collect evidence, or in other words, a sample to test the statement. And then you're going to analyze the data to assess the plausibility of the statement. I think that was it. Yeah. Steps. All right, and we're still holding on to the sheet before we go to the next one. All right, good, good, good. All right, so we have two types of hypotheses. You see that? Oh, yep. So there's your null hypothesis. It's denoted by HO or H naught. That's what we say it, H naught. It's the statement to be tested. It's a statement of no change. Should be an E right there. I left the E off and change, but no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. Your alternative hypothesis is denoted by H1, H sub 1, and it's the statement we are trying to find evidence to support. So So H naught, your null hypothesis, is a statement that you assume to be true. And then your alternative, your alternative way of thinking or your alternative hypothesis is the statement that you bring and you're trying to support, find evidence to support. All right. Still see copying. All right, can I go to the next page? Everybody good? Thumbs up, thank you much. All right, so here are our three tests, our three scenarios. See if I can get all three of them in here. Yeah, there we go. So we have two-tailed tests. Notice, and let me see if I can't write on in this state. Okay, so notice when it comes to these tests, we have we have the two-tailed, left-tailed, right-tailed. Now, left-tailed and right-tailed, both of them are one-tailed tests. But what I want you to do is to recognize that all of these are the same in setup and everything, except for one thing. Notice here, this is all the same. Here, this is all the same. And then here, this is all the same. The only thing that's different is this symbol. And that dictates which test you're actually dealing with. Or that test will dictate what symbol you're going to use. So I just want to make sure we point out that. So the first one on top is your null hypothesis. Your null hypothesis will always be equal. Whatever your parameter is, equal to that number. Like I said, it's always equal. The null hypothesis will always have the equal sign. So if it's two-tailed, that means you would be using not equal in your alternative. And there will be keywords, just like in last section and last chapter and chapter before that, 7 and 8, keywords dictated what we would be doing with our z-scores, whether it was less than, you're talking about lower, under, something like that, or better, greater than, that type of thing. That would tell us what symbol to use. So here, keyword here would be different. If they say, what's the probability of something being different? And, we dealt with less than before. And then here, keyword here would be greater than. So keywords will dictate, and you'll see when we get to the examples, keywords will dictate what symbol we'll use for our three tests. All right. Also in reference to our normal distribution, notice two-tailed, here's the diagram here, left-tailed, because the tail, the shading that we were using would be to the left, and then right-tailed, shading we're using would be to the right. All right. Still copying. Can I scroll up? All right. Cool, cool, cool. All right, so here we're going to get a little writing in so we can put into practice what we just finished talking about, at least setting up the null alternative, the null hypothesis and the alternative hypothesis. So directions determine the null and alternative hypothesis, state whether the test is two-tailed, left-tailed, or right-tailed. Now, as far as your hypothesis testing, this is just the setup, but we're just trying to make sure you're good with the setup, before we go further in your testing. All right, so we got medical pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So I'll give you a chance to write that down before we explore setting up the null and alternative hypothesis. All right, so let's look at setting this up. If I had, well, I guess I could have wrote it on the notes, but it's all good. So let's look at how we set it up. You always start off with H naught and H1. Those are the first two things that's setting up your alternative hypothesis and your null hypothesis. So, this is your null. This is your alternative hypothesis. So we're looking at percentage. So I just use P as my parameter or my proportion. So that's why we're using P. This is always equal, always equal. So it's always, and then the number that we're looking at, the parameter that we're looking at is percentage, 2%. So as a decimal, you write that as a decimal, and that's why we have that here. Now don't forget, if I put P here, I'm putting P here. If I'm using 2% here, I'm using 2% here. So those always going to be the same. Whatever is in it, your null hypothesis, you're challenging that same statement in the alternative hypothesis. So these are got to be the same. They have to match up. And so now the main thing is what symbol is this going to be? And this symbol is greater than because it says more than right here. All right. Questions on what we did as far as setting it up. And because it says more than, that means it's right tail. All right. Any problems with that setup? All right, let's see. We are still copying, correct? I see a thumbs up saying we're good. So I'm scrolling up. Next one. All right. So next one. We have the blue book price of a used 3-year-old Chevy Corvette is $86,012. Grant wonders if the mean price of the used 3-year-old Chevy Corvette in Miami is different from $86,012. Once again, give you a chance to write that. Trying to send this file so I'll be able to put it up for you guys. All right, so setting this up once again, HO, H1 or H naught and H1. Now this time my symbol I'm going to use is the mean. So that's why I use my mean symbol. That's about the mean price. Once again, this is equal. And we're using the number 86,012. Now here the keyword is different. So that's why we use not equal to. So we're not about necessarily it being greater than, it's not about it necessarily being less than. It could be either or. We just want to know, is it different? And so that's why it says, that's why we're using the not equal to symbol. And then because we're using that symbol, that's also letting us know we're going to have a two-tailed test. All right. Question on that. All right, going to the next one. Last one like this. The standard deviation of the contents of it in a 64-ounce bottle of detergent using an old filling machine is 0.23 ounces. The manufacturer wants to know if a new filling machine has less variability. All right, so this time, once again, well, you know that's going to be the same. That's always how you set it up. But the symbol we're using here is a standard deviation because it's talking about a standard deviation. So using that symbol. Once again, this is always equal, and then the number in question is 0.23. So that's why we have the 0.23 there. And then the keyword is less than, so, or less variability. So that's why we're using the less than symbol. And then that also means that it's left tailed.
Professor, what makes something left-tailed again
Less
or
than,
right-tailed?
less than, that
Oh, just
keyword. Yeah, it's going to be the keyword. It's going to be a keyword to let you know if it is said the filling machine has greater or larger variability, then it would have been a greater than symbol. And then that means this would have been right tailed.
okay. Okay.
Yeah. Yeah. So that makes sense. That's okay.
Yeah, it makes sense. It makes sense. Okay.
Okay. All right. Just want to make sure you're straight. I know if I need to say it a different way or not. Yeah. All right. But yep. So going back to your question, guys, it's always going to be based on the keywords, what symbol this will be. You know, if it says less, lower, under, shorter, you know, something along those lines is going to be a less than symbol. Is going to be our left tail. Um, going back here, different means we use the not equal to symbol, and anything suggesting greater than. So you just said more than, greater than, taller than, hotter, above, something like that means greater than. So we use a greater than symbol, and that means it's going to be right tail. All right. Any other questions before we go anywhere else? All right. Can I scroll up? Anybody? Thank you, thank you. All right, so let's look at these outcomes, 4 possible outcomes from doing our test. If I can get all 4 in here. So we're talking about rejecting the null hypothesis when the alternative hypothesis is true. So that's a correct conclusion. We will reject the null hypothesis when the alternative hypothesis is true. Do not reject the null hypothesis when the null hypothesis is true. Once again, a correct conclusion. Notice the third one, reject the null hypothesis when the null hypothesis is true. That's a type 1 error because you don't want to reject the null if the null is true. And do not reject the null hypothesis when the alternative hypothesis is true. Once again, that's an error, but that will be considered a type 2 error. So I'll give you a chance to copy those down. All right, can we scroll up? Pretty good. All right, so last thing on the sheet, level of significance that's denoted by Greek letter alpha. Kind of look like that fish. It's Greek letter alpha. And it's the probability of making a type 1 error. All right, everybody got that before we go to the next thing? All right, so switching back to notes. So under the red is where we're starting now. So like I just mentioned, alpha is probability of making a type 1 error. Beta, Greek letter beta, is looks like a B for us, but it's B with a little bit of a longer stem. That's the probability of making a type 2 error. And so, of course, you wouldn't copy, that's just me noting myself, giving me a note, talking about picture notes first. But so the difference in the two, we talked about as far as description is concerned, but the probability of making a type 1 error is chosen by the researcher before the sample data are collected. So in our problems, you'll see when we get them, they're going to give us that probability. So it's nothing for us to do. But if you were doing this by scratch, initially by scratch, you would choose the type 1 error probability. So the choice of the level of significance alpha depends on the consequences of making a type 1 error. So give you a chance to write it before I keep going though. All right, scrolling up. If I scroll up too much, let me know. So if the consequences are severe, alpha should be small, 0.01. This example of that. But if the consequences are not severe, a higher alpha can be chosen. So 0.05 or 0.1. All right. All right, so when we talk about the consequences, the level of significance is not always set at alpha equal to 0.01. That's the smallest one that's normally used as far as our common ones, because reducing alpha increases the probability of beta. So that's what you're talking about, consequences. Which one are you willing to deal with, the chance of happening the most? Because if you, once again, reduce alpha, that increase the probability of beta. They have an inverse relationship. As one goes up, the other one goes down. All right, so I believe that's it for 10.1. So just talking about the inner workings of setting up your hypothesis testing. This. Trying to pull up this assignment so we can do a few problems. All right. All right, so that's it for 10.1. Before we look at 10.2, is everybody good? All right, should be okay. There now 10.2. All right, I'm gonna do a few problems out of 10.2 homework. Let's see, I need to share this. Oh, that didn't come out. Hold on one second. Here we go. All right, so I will send you a copy of this. It's your hypothesis testing, steps 1 through 5. So we've actually talked about step 1, which is which is right here, setting up our hypothesis testing, alternative and our null hypothesis. So that's that first step. Step 2 will be given to us. In all the problems that we have, they will give us what our level of significance is. And then we have the classical approach and then the p-value approach. All right. So yeah, we can go ahead and do it today. Let me see. Do we want to do it today? Do I want to send this to you? Let's see. Next class, Monday. All right. All right. I'll let you guys let me know what y'all think. Do you want to do 10.2 today, or do you want me to send this to you first so you have it in front of you to do 10.2? Anybody care? All right, somebody said they don't care. So all right, so we can just go ahead and try it out. All right, so let's look at homework. So number one is just a problem. Number two. Okay, so all right, so looking at number three, I have some numbers. You don't have to copy down the numbers. I'm just letting you know how it's set up. Looking at number three, they give you your null hypothesis. They give you your alternative hypothesis. They give you n. They give you x. They give you alpha. So in this problem, they give you everything, and then they ask you to perform the test using the p-value approach. So I'm going to go to the notes. I'm not telling you copy down those numbers. I already have numbers in some notes, but I'm just showing you when you go into this homework what they give you initially. All right, so let's go to number three. So number three, these are numbers that we have. These are ones you want to copy. They give us null hypothesis, p is equal to 0.70. Alternative hypothesis, p is less than 0.70. Our sample size is 150. X is 95. And which is our, value in question, data value in question. And then our level of significance is 0.01. And they ask us to perform the test using the p-value approach. And going back to, just want to make sure I emphasize this. Once again, they give us a p-value approach and they give us a classical approach. So they asking us to do the p-value approach, which is over here to the right. So once again, I'll send you guys a copy of this today. As a matter of fact, let me write myself a note. Where's my note sheet? And the other one, gotta send you guys 2 emails today. Okay. All right, so we're gonna use X and N to find P hat. So that's what we do first. So out of what the X is out of the 150 people sampled, 95 people took on this characteristic. Like I said, this problem, they didn't have any data like that. They didn't tell you what a characteristic is. They just gave you information. So we just going according to the numbers that we have. But we had a sample of that when we were dealing with stuff in chapter 8. We had different characteristics out of that sample. All right. So next move is to find your test statistic. So we found p hat, our sample proportion, to be 0.6 with 3 repeated. You don't want to round it off to just 0.63. Notice what I did here in my calculation. I went to like 5 decimal places. You want to get the most accurate answer possible. So you want to run that 3 at least 4 more times, 5 times when you do your calculation. But this is the formula to find your test statistic, and it is on that sheet that I'm going to send to you guys today. All right. So this is me just doing the work.
Oh, Professor, could you scroll up a little bit, please?
Not at all, sir. All right, hold on a second. Let me get up there. How far you want me to go up?
Right there. That's fine.
All right. I use a calculator. Some people just put it in the calculator after this step. You just plug it in, use the parentheses properly and everything. But that was just me walking through some of the steps to make it as easy as possible. Everybody done with the red? All right. So once you get your test statistic, you go to the chart. That's just like our Z-scores. Go to the chart. with that negative 1.78. That's why we round it to 2 decimal places. And our p-value. And always remember that goes based on, I'm gonna scroll back down. Remember, we're dealing with less than as our symbol. So we use that chart value. All right. Now let's see, they asked for the p-value. Let's see if they asked for anything else. Perform the test. Okay, yeah. Can I scroll up a little? Is everybody okay? All right, so now we're going to take that p-value and compare it to our significance level, that alpha that they gave us. So once again, remember, they're going to give you alpha. But if you're doing this on your own from scratch, then you would choose your own alpha. So, and this is on that sheet, you know, what decisions you make based on whether your p-value is greater than alpha versus less than alpha. But since the p-value is greater than alpha, we do not reject the null hypothesis. And that's all they want from me out of that problem. All right. Questions on that? Questions on that? All right, can I scroll up to number 4? All right, let's see what number 4 asks of us. Okay, so let's look at number 4. So notice how number 4 sets us up, test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. So notice how they gave us everything once again, but then they asked us the question, is n times p naught times 1 minus p naught greater than or equal to 10? So the reason why they're asking us that is because our initial conditions, we go back here, and like I said, this is the sheet that I'm going to give you. Notice you have these initial conditions that have to be met. We talked about those before as well. So it leaning on stuff that we did in our previous chapters. So the sample is random, but then right here, the sample size times p naught, your population proportion, times 1 minus p naught, is that greater than or equal to 10? So that's what we're talking about challenging right there. So let's go back to the notes. All right, so this is the information here they give us. Let me erase this first. Yeah, that's fine. So they give us all of this information. P is equal to 0.81. P is not equal to 0.81. So, you know, that not equal to lets us know it's two-tailed test. Then N is equal to 500. X is equal to 390. And then alpha is equal to 0.1. I'll write something just a little better. All right, so they want us to test this statement first. P naught is this 0.81. That's your population proportion. And so that's what we did right here. 500 times 0.81 times 1 minus 0.81 ends up giving us 76.95, excuse me. And that is greater than or equal to 10. All right. So now, once we've established that, that lets us know we'll be able to do the normal distribution or it's normally distributed based on that type of declaration. That means we know we'll be able to do the z-score. So the next thing we do is find p hat. We do x over n. That's 0.78. And then from there, we do the same thing we did in the previous problem, p hat minus p naught over the square root of p naught times 1 minus p naught over n. So that's that formula to get our test statistic. All right, can I scroll up? All right, so everybody good? Got negative 1.71. Like I said, z-score, so you rounded to 2 decimal places. Then you hit the chart, get that chart value of 0.0436. So now it's two-tailed. So we have to operate this way. Notice I have the negative 1.71 over here, but since it's two-tailed, I'm also going to have the positive 1.71 on the other side. And that 0.0436 that I got from the chart will be on both sides of that 171. And so whenever we have a two-tailed test, we're going to multiply that p-value by 2, which gives us 0.0872. And our alpha was, let me go back, I didn't write it down there, 0.1. So our p-value is less than that alpha, so we're going to reject the null hypothesis. So if p-value is greater than alpha, you do not reject the null hypothesis. If the p-value is less than alpha, you reject the null hypothesis. All right, any questions, any questions? All right. Head this up, let's see. Can we scroll down to the next one? Anybody holding on to it? All right, I meant to, let's see, I think I'm good. Okay, so let's look at number 6. No, I got a lot of writing up there, but let's look at what number 6 tells us or asks of us. All right, so this one is actually a word problem. Let me go back to my stuff. Okay, this one I'm going to use the classical approach. All right, so here we have a certain drug can be used to reduce acid produced by the body and healed to the damage to the esophagus due to acid reflux. Manager of the drug more than 92%. Take the drug within 8 weeks. Blah, 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 blah. Okay. So notice this time they give us a word problem. It says a certain drug can be used to reduce the acid produced in the body and heal damage to the esophagus due to the acid reflux. The manager of the drug claims that more than, so there go our key phrase there, more than, that means it's going to be greater than right tail. More than 92% of patients taking the drug are healed within 8 weeks. Clinical trials, 223 of 237 patients suffering from acid reflux disease was healed after 8 weeks. Test the manufacturer claimed at 0.01. All right, so here we do the test. Let's go ahead to what numbers I have. All right, so instead of 92, I had 94%. And once again, this is me putting in the more than. So any questions on the setup? Notice they didn't set it up for us this time. They gave us 92% in the problem that we had. So this problem I have was 94%. And that's more than. More than, let's just use the greater than symbol. Is everybody okay with that? All right. So then they ask us about our initial condition. So sample size, 225. They gave me 214 of 225. So the 214 is my X, 225 is my N. So that's where I got 225 from. And then my P naught is the 94. Remember I told you about that before as well. Whatever that initial percentage is, that's your P naught. And so here I ended up getting 12.69, which is greater than 10. That allows me to continue on with my normal distribution and Z-scores or whatnot. All right, here, calculating P hat by taking that 214 or 225, doing 214 over 225, and getting that number, which is 0.951 repeat. So before I go to my test statistic, is everybody okay with what we pulled from the problem? All right, so once you have that established, you can go and use your, find your test statistic. That's what we do here, P hat minus P naught over the square root of P naught times 1 minus P naught over N. Once again, I had that 1 repeated over here, so I wrote it multiple times just to give myself the most accurate answer possible. Let me know if I scroll up too far. So there goes my Z-score. My test statistic, 0.70. Any problems? So here I ended up just deciding to use the classical approach. Let me see. Let me see if this one makes you use the classical approach. No, the other one said use p-value. C alpha. Well, anyway, I use the classical approach on this one. Give you guys a sample of that. So notice in the classical approach, when you get your sheet, you'll notice it mentions Z alpha. Alpha that was given to us was 0.1. So there's Z 0.1. And let me show you this. Is it down here? No, it must be on the Z-score chart. So I'll take you back to the notes. Yep. All right, so on the Z-score chart, notice down here at the bottom, hypothesis, won't let me write. Hypothesis testing, critical values. So 0.1, if it's right tail, left tail, or two tail, you would use these values right here. So that's if you're doing a classical approach. So if I'm not mistaken, we were more than, yep. I can pull my stomach up. There we go. So we're going to use, since we're dealing with more than, we're going to do right tail. That means we need the 1.28. So that's how you would use it if you're using the classical approach. You go back to your Z-score chart and go down here to the right column. So if alpha was 0.05 and we're doing right tail, then I will use 1.645. All right. So that's why I have 1.28 right here. Then, according to our directions, we will compare the Z naught, which is our test statistic right here, and Z alpha, which is 1.28. If Z naught is less than Z alpha, then you do not reject the null hypothesis. Once again, all of these steps are lined up or laid out in that sheet that I'm going to send to you. It's in the book as well, but I'll just send it to you. All right. Questions on the process? Any questions? Any questions? So, as always, some questions may not show up until you actually get in there and try to do it. And I understand that. So, that will be you guys' challenge to get in there and try to take care of it and see if you have any issues. And then, bring them to class so we can talk about them. All right. So before I move off of this and we look at how we're going to operate moving forward, questions? Or anybody still copying? Oh, what happened to my notes? Okay, there we go. All right. So let's look at how we're going to operate moving forward. That's our last piece of new material. So our final exam, I went ahead and decided that's going to be August 4th, which is a Wednesday. That's our last day of class. So if you look at what we have set up, we have the 26th, 28th, August 2nd, August 4th, which is the final exam day. So you get your full 2 hours. Our class is from 1 to 3. So you get, that amount of time to knock it out. I'm not saying that the final exam is created to take up for, the full 2 hours, but you just have that at your disposal. And I'm going to send you an email. Remember, I don't know if you heard me talking to myself. I said I need to send you guys 2 emails out. That's the second email I'm going to send you. Hopefully I can get that out to you today. Final exam details. Basically have your date, time, what I'm telling you now, but also details on how we're going to operate on that day. At some point, you're going to see the final exam pop up as an option in my math lab. If you click on it, it's going to ask you for a password. You do not have to send me an email asking for the password. You're not going to get the password until final exam day. On that day, our final exam is supposed to be proctored. We are proctoring our final exam. So you're going to come in, take it. You're going to enable your camera, show your ID to the camera. And then after you show your ID, I will shoot you the password.
I think your signal went out. Now we can't hear you.
All right, there we go. So now everybody can hear me, right? Everybody good? Okay,
Yeah.
thanks, appreciate that. I got kicked out, you know what I mean? Who knows what happened with that? But that's the day we live in, right? If we were in class, I couldn't get kicked out, but but that's just how it is. So All I was doing is explain the final exam process. Let me go back to it. So just saying, and you can let me know if where I was, if I missed anything. So all I was saying is that on that day, you're gonna enable your cameras. Everybody have to enable your cameras. So if you need to get your hair done and all the good stuff like that, make sure you do it for that day. So enable your camera.
Yes.
Somebody say yes. I know it's out there somewhere. Somebody got to make sure their hair is done. So on that day, you enable your camera, show your ID to the camera, leave Zoom, stay connected to Zoom. I've had people in the past that will get on, show the ID to the camera, I give them the password, and then they get out of Zoom. But we're supposed to be proctoring this thing. I have to proctor you guys to some degree on that day. So at least if nothing else, I can say I tried, So you're gonna enable your cameras. Oh, hit my cord. Enable your cameras, stay connected to Zoom. Now you can, go to other windows, but what you don't do is hit the red X. You don't close out Zoom, but you go to other windows, go into my math lab. I'll give you the password. You will not get that password until the day of the final exam when you log in on that, between 1 and 3 block. So you don't have to ask, I need a final exam. I need a final exam password because you're not going to get it until that day when we actually proctor it. Now, a makeup will appear later on, about a half an hour after class is over, which you can take advantage of. Now, the highest score you can get on that makeup, you're talking about makeup, probably show up around 3:30. You will not see that as an option before then. And that is not proctor. You do it on your own time. You will have until August 8th, because just like anything else in my math lab, we have until August 8th to take advantage of it. The highest score you can get on that is a 75. Now, that does not mean I take off 25 from whatever your score is. It just says the highest score, the cap that you can get on that is a 75. So in other words, if you score 100, the only thing I can accept in that is a 75. But if you score 72, your score is 72. I'm not going to take away from anything. So really, you would only try to do the makeup if you scored less than a C. Then that's the only reason you would go and do the makeup. Now, scoring a C or 75 on your final exam will not stop you from getting an A out of the course. So
wait, is the makeup like a retake basically?
yes, it's a retake. It's just not proctored. It's not proctored. So it's just giving you the opportunity that if you score less than a C, that you can at least get a C on the final by taking advantage of the makeup. Like I said, if I got an A or B, then there's no need for you to do the makeup. It's really for somebody who scored less than a C on the final exam. And it's going to be the same exact final. It's just that it's not proctored. You get to do it on your own and your own time. What else? You don't need a password for it or anything like that. And oh yeah, that's what I was getting at. So having a 75 on the final exam does not stop you from getting A out of the course. So it's really not going to mess you up. It only can help you. What will stop you from getting an A out of the course is everything you did leading up to the final. So I just want to throw that out there. So, but I do have to have these type of things in place because, if I just have a free fall and there's nothing in there, like any type of penalty, then, if somebody were to come audit the course, they can be like, well, everything was done, take home, nobody, no monitoring, anything like that. So I have to have certain things in place like that. But like I said, that will not stop you from getting the A out of the course. Everything else leading up to it can though. So you do want to make sure your grade is solid, leading up to the final exam. And then, you'll be good to go. Questions on any of that? Questions on any of the process?
So I'm gonna be in like Timbuktu at my mom's house. So I'm gonna try and connect on my phone and
Okay.
then do it on my computer. I don't know. It's gonna be interesting. I might be very blocky, but
Okay, not a problem. And I was about to mention that as well. If you're gonna have some type of issues or concerns about making it that day, then make sure you shoot me an email individually, and we'll handle individual situations. I may have a solution for it, may not. We'll just have to have that discussion. But that's that's an individual situation. So if you want to try to see if we can figure out something, then shoot me that email. We can talk about it and go from there.
I'm gonna do a test run when I get there to see how bad her internet is.
Okay.
So
Okay. What, what's the earliest you're getting there?
I'm gonna leave next Wednesday after class, so
Oh, okay, okay. So you're gonna spend some time there. Okay. All right. So yeah. So yeah, try it out. Let me know. We'll go from there. All right. Anything else? Anybody else?
When you say ID, do you want our student ID or?
Preferably, but people have not had the student ID in the past, so they showed me like it was a picture ID, at least a picture ID.
Okay, yeah, because I don't have one because I signed up for like this summer class and I've never actually been on campus, so
Oh
I never
wow.
got
Okay.
one.
Yeah. Not a problem. I completely understand. So if you got, driver's license, something like that, you just throw it up there and that'll be fine.
Okay, thank you.
Not a problem. Anything else? Anybody
Okay.
else? Uh-huh.
Yes, I have a question. So will the test start like normal class time?
Mm-hmm.
Be the like start time?
Mhm.
Okay, okay.
Yep. If you show up late, then I mean that's cool, but that's just cutting into your, time. Just like if we were in class, regular class, you would come in between 1 and 3 and take that final, and then at 3 o'clock, that will be, it. So it will be a 2 hour, time on that. Your makeup will not have it will not be time, but the final exam will be a 2 hour time slot. The initial final exam taken will be a 2 hour time slot.
I have a question.
Mhm.
So what day does class end? Because on Math Lab it says it ends like, or I guess our textbook expire. I don't really know. It says like class ends on the August 15th, but I thought it ended before that. Is that just when our textbook expires? Or yeah, when our textbook expires?
Yeah, that's just when the class shell will close out completely for you guys. I always put a date out there, like a buffer, just in case I have some stuff that even myself I have to go in and do stuff and finagle. But yes, you guys, the date that you guys are looking at is August 8th, which is a Sunday. So that's the last time you guys can submit anything. Outside of weird stuff, but that's individual cases. But we're talking about the class as a whole, August 8th. Yep. Hopefully that answers your question, what you asked. All right.
Yes,
Yeah.
thank you.
Yep, not a problem. All right. Anything else? Anybody else? Anything else? So from this point forward, just review until August 4th. So the 26th, 28th, and the 2nd, I'm not coming with any type of new lecture, not coming with any new material. I'm coming to class and seeing if anybody has questions. And that's just it. So if we come on the 26th, nobody has any questions, and nobody says, hey, could you try, not try, but could you do a problem such and such? Because I have trouble with it or something like that. I don't have anything. So that's it. So we have these 3 days for you guys to ask whatever y'all want to ask of me, pertaining to the course. And that's
and the
it.
last two homeworks are 10-1 and 10-2, right?
Yes. 9-1 you do not have to do unless you just, want to throw in some extra credit, try to get extra credit, but it's not necessary because whatever was in 9-1 that we needed for 10-1, I just went ahead and incorporated it in our lecture. So we don't need to do a whole nother section for that. All right. Anything else? Anybody else? And if I'm not mistaken, the review, final exam review is posted. Yes, final exam review is posted. So you can take a look at that, see if you have any questions on that as well. And yeah, that's it, man. We almost there. Almost there. Any questions? Let me see. I posted chapter 4's test. Yep. So any questions before we close today? All right.
Oh, will
So
you loading the lecture from the other day from Monday?
yes.
Okay.
And what did you ask about the lecture?
Oh, will you be uploading it today or
I'm gonna try to get it. Yeah, I'll try to get it today. Try to get it
Okay.
out there for you guys today. Try to get those emails to you and that. Yep. All right. Anybody else? Because when I send that, I'll send this one as well. So all right. All right. So you guys have a good one. Be safe. Have a great weekend. Hey, it's review time now. So let's go ahead and close out the class, and, real strong. And I hope you guys get the grades you're trying to get. All right. So you guys have a good one. Be safe, and I'll see you on Monday.
Thank you. See you Monday.
Thank you.
Thank you. Have a good one. Take care.
Thank you.
Thank you.